Alright, so the first thing you have to do to solve this problem is to write out the chemical equation. This unknown compound is burning oxygen, which just means add O2, and the products are always going to be carbon dioxide and water. Next, I like to label the given information, which is 0.200 grams of the unknown compound, 0.293 grams of carbon dioxide, and 0.120 grams of water. Next, we're going to convert the grams of carbon dioxide into moles by dividing by the molecular weight of carbon dioxide, which is 44.0 grams per mole. And you get that you have 0.00666 moles of carbon dioxide. Next, you have to recognize that the ratio of carbon dioxide to carbon is 1:1. So you're also going to have 0.00666 moles of carbon. Next, you're going to convert the moles of carbon into grams of carbon by multiplying by the molecular weight of carbon, which is 12.01 grams per mole. And you get that you have 0.08 grams of carbon. Next, we're going to do the same thing for water. And we're going to take the grams of water and convert it to moles by dividing by the molecular weight of water, which is 18.016 grams per mole. And you get that you have 0.00666 moles of water. Then you have to recognize that the ratio of water to hydrogen is 1:2. So in order to get the moles of hydrogen, you're going to have to multiply the moles of water times 2. So 0.00666 times 2 equals 0.0133 moles of hydrogen. Next, you're going to convert the moles of hydrogen into the grams of hydrogen by multiplying by the molecular weight of hydrogen, which is 1.008 grams per mole, which gives you 0.0134 grams of hydrogen. Now that you have your grams of carbon and your grams of hydrogen, you can subtract it from the mass of the unknown compound, and if you take away all the carbon and all the hydrogen, you're just going to be left with 0.1066 grams of oxygen, and you're going to convert that into moles of oxygen by dividing by the molecular weight of oxygen, which is 16 grams per mole, and you get that you have 0.00666 moles of oxygen. Next, you're going to take all the moles of oxygen, carbon, and hydrogen, and you're going to divide it by the smallest mole ratio, which in this case is 0.00666, and you get that your empirical formula is CH2O. Now, the second problem in this less practice is just like the first one. So we're going to set up our chemical equation, and then we're going to label the given amounts. Then we're going to convert the grams of carbon dioxide into moles by using the molecular weight of carbon. And then we're going to use the mole ratio of carbon dioxide to carbon and to get the moles of carbon. And then we're going to multiply times the molecular mass of carbon to get the grams of carbon. We do the same thing for water, where we take the grams and we convert to moles by dividing by the molecular weight of water. And then we recognize that the mole ratio of water to hydrogen is 1:2. We multiply the moles of water times 2 to get the moles of hydrogen, and then we convert moles of hydrogen into grams of hydrogen using the molecular weight of hydrogen. Next, we subtract the grams of carbon and the grams of hydrogen from the mass of the unknown compound, and we get the grams of oxygen. We convert that into moles using the molecular weight of oxygen. You take the moles of oxygen, of carbon, and of hydrogen, and you divide by the smallest mole ratio. In this case, it is 0.0217, and you get that your empirical formula is, but wait a minute, our empirical formula has non-integer values. So we're going to have to multiply this whole ratio by 2 in order to get integers, and you get that your empirical formula is C4H11O2. Thanks for watching!